other than southeast Iowa. So one of the things about southeast Iowa is that we are in a latitude, as you know, that we have seasons. It's not that to say that if you lived at the equator you wouldn't have seasons, because you do. But we're going to see that we have a pretty much a swing in temperatures that like the equators don't see. Even folks in Florida don't see the seasons that we see, right? So that's one thing about it. So I've got this is a slide on the whole statistics of kind of like the daily average temperature, okay? So you have a couple of choices there. One is to basically take it every hour for 24 hours, add those temperatures together and divide by 24. The other is for a given day to look at the max and the min and to average the two. Temperature swings are important in this chapter. A temperature swing is basically the difference between the high and the low temperature. So for every day there's a temperature range, okay? The high minus the low. So then from daily we go to monthly, and as you might imagine, to get the monthly average, however many days you have in that month, you add all those average daily temperatures together and divide by that number of days. Every once in a while I'll throw one of these on the test because I'm looking for some sort of, like if temperature of 2 days was 44 and 46, what's your average temperature? 45, something like that. We'll see. But then it comes to, for the year, for a given location, okay, what is the temperature, the average temperature? And so what they usually do is turn for that location to the monthly temperatures, add them together and divide by 12. For a given location, what sort of temperature range do they see throughout the year? Well, again, they look at the monthly temperatures and they take the high minus the low to get their range. Okay. So I want to talk just briefly about weather maps again. But to talk about weather maps, and we talked just a little bit about them in the first part of chapter 1, I'm going to introduce this general idea of contour maps. And if you've done much with like elevation maps, the contour maps, that's a type of contour map that connects locations with the same elevation. But in weather, we're interested in things like temperature, pressure, wind speed, okay? So we draw contour maps that connect locations with the same, in this case, temperature. So we looked at this one earlier, and first off, if you are, let me find, oh my goodness, okay. So is this Iowa? Go back. No, don't go there. No. Yes. Drawer. Is Iowa right there in the continue? Okay. Oh, yeah, thanks. That didn't look like Iowa. Now that, yes. Oh, I see it. Okay, we're hiding right over here. Right, that. Very good. Wow. So what temperature do you think we are-ish? In the tens, in the teens? I agree. Yep, I totally agree. So the way this has to do with contour lines is that, let's see, all of these locations right here, okay, to me they're transitioning from 0 to 10s. So where I have the dots, I think that's 10. You buy that? Okay, and I'm going to draw the dots then. I'll draw a purple line where it goes from 10s to 20s. Okay, that is at 20 degrees. All of these locations are at 20 degrees. How do I know that? Because it's smack dab between the 10s and the 20s going up. Okay? So those are contour lines. And we call those, by the way, those dots were isotherms. They're a special type of contour line called an isotherm. Therm meaning thermometer, right, temperature. Well, there's also a contour map that actually looks at atmospheric pressure, and those lines are called isobars. And this actually was back in chapter 1 too, because remember, it might be too small to see, so I'll just kind of, these up here, those way up there, let me pick a better one. Here, this one. Yeah, that one's better. Does that look like 1024? Okay, so actually, what they're saying is all of these locations are at 1024 pressures, units of pressure, and we'll be talking about what millibars are. Millibars. You know, like milliliters, but millibars. Okay? So those are connecting locations that have the same pressure. And what did we say the H stands for?
High pressure.
High, very good, high pressure. Yeah, high pressure, usually no clouds, that's right. Low pressure, we definitely see some clouds there. So the way this would work is if we pick on that low, that's kind of Midwest-ish, kind of near the Great Lakes, this guy right here. If that's low, then if we look at, it's what we call a central, I use the word central, so do meteorologists, central or middle low. As we go up, those contour lines, or if we go out, those contour lines should get higher, shouldn't they? Okay, and I can read the 1004. Looks like each gradation here is 4 millibars. So 1004, 1000, 996, 992. Okay, so that's how that works. Pressure is definitely, what the pressure is doing at the Earth's surface is definitely a player. You heard in the video, they got to the part to talk about winds. Winds always go from high to low pressure, but usually not in a straight line because the Earth is spinning. So usually they twist around. Okay, so those green lines are called isobars, and then I have isotachs. Okay, so the way, I don't have numbers here for you, but isotachs then connect locations with the same wind speed, like a tachometer, I think so. And I don't have numbers, but the more the flags, the faster the wind's blowing. So you've heard of the jet stream. Actually, the jet stream there is kind of indicated in pink. Okay, so these have the most flags. Okay, the wind in that groove is going the fastest. And then on either side, the wind slows down.
That'd probably bring a pretty good storm.
Mm-hmm. It could. It could definitely bring us some cold. It could create a kind of a blocking event that can bring us that polar vortex, cold air mass from the Arctic. Pinches it off. So whether it's these contour lines, whether they're connecting locations with the same temperature, with the same pressure, with the same wind speed, in general they are called isopleths. That's like the generic name for them. It's kind of a weird name, right? Okay. Yeah. So I brought in one more, and actually clear when we talk about severe weather, we're going to get to this scenario. I can't remember what year it was, but of course you kind of see the radar, you see the precipitation with the greens, and what's the oranges mean? Heavy precipitation, exactly. And one of the things is, do you guys buy this? And if you've worked with elevation maps, you know this, that if you have elevations that are very close together, that means you don't have to go very far before you get a big change in elevation. So also, if you have any of these contour maps, if the lines are close together, watch out. So tight isobars are not a good thing. It means basically you have a drastic pressure change in a short distance of time. Okay, so we'll be talking more about that. So weather maps. So these are, this whole chapter, chapter 3, is talking about surface temperatures. And at the end of the chapter, I'll kind of tell you that we said that those ASOSs measure temperature, those things by the airport, kick out the temperature, like every hour, or gosh, when we looked at Keokuk, it was like every 15, 20 minutes or something. Okay. Yeah, it's like an automatic thing. It just automatically kicks it out. but they are like about 6 feet, off the ground. It's like a standard. Okay, so these are all surface temperatures. And you see the color image, and actually these are the same. This is just in color, and this is with the contour lines. Okay, so the contour lines are major tens temperatures. Okay, so it's all about temperature. So let's see what we got. This link right here, historic weather maps. I just thought this was neat. A few years ago. There we go. I think I may have told you already, the older you get, the more you appreciate history. I don't know, but so anymore we have those devices near airports that are kicking out the temperature, and that's what they do all day. We have the internet that we can at any time, get in the middle of the night, you want to know what the weather's going to be, you know, you look for forecasts on the internet. But before computers, these things were hand-drawn. And I imagine horses carried them from one location to another. Okay, so I just thought that these were kind of neat. 1871, War Department weather map. 1872. This one right here, you know, we've talked about ISO bars connecting locations with the same pressure. And ours are usually like 1,000 something, like millibars. These are actually, do you recognize inches of mercury? Okay, so this is an isobaric map. I'm showing you. I just think that's neat. And you kind of see the station models. We talked about that before, where we have an assortment of locations that looks like they knew maybe whether it was cloudy or clear and the wind direction.
It kind of looks like a bad day because all those bars are close together.
Yeah, they do look kind of tight over there. I agree. It's like, beware. Okay. So we talked about how you, for a given location, get the average daily temperature, get the average range, the daily temperature range, the monthly temperature, the yearly temperature, the yearly average, and all that. And I hope these are still accurate, but at the time that I chased them down a few years ago, or that these might still even be in your book, for North America, for our continent, the hottest temperature ever was 1913, recorded in California. Okay, the world hottest temperature was just a few degrees warmer in Libya. Then I have let's see if this video, maybe. Well, we'll see if this coldest works. So again, in North America, -81. In Canada, right?
Dude, that doesn't even that's not even
-129 in the Antarctic.
like that whole -81 thing, that might as well be Canada. Alaska, I don't even consider that America.
Yeah,
Still.
that -10.
That's cold. I'm not
To
going
us,
outside if it's
to
negative.
Alaska, that's like t-shirt weather.
Yeah,
That's
I don't
probably
know.
true. I mean,
But, so we're actually going to kind of talk, it's, you know, it's like if you buy a house, it's location, location, location. You know, if your house is going to be expensive or easy to sell or hard to sell, so location. So this is all about location and the whole temperature, what's going on with the temperatures. So one of the things, actually, this is pointing out, not so surprising, is that the temperature, now we're going to see a lot of these boxes. So I hope you like these boxes. This J stands for what?
January.
Very good. January through December, okay? And then actually this is temperature in Celsius, and that's temperature in Fahrenheit. So just at a glance then, we can see, and by the way, your author does a good job, I think. He goes ahead and says what latitude. Florida is about 25, okay? New Zealand, southern hemisphere, about 37 degrees south of the equator. Russia is north of the equator, about 55. Then we have something about on the equator, okay, less than a degree off of the equator. Okay, so that's kind of what we have going on. Not so surprising. If you live in Russia, is it generally cold? Maybe, maybe not. Well, let's see. Russia, the northern hemisphere, should they kind of track with our temperatures? Okay. So let's look at their summer, June, July. Yeah, it stays, I'd say that's cooler than here, wouldn't you?
Yeah.
Yeah.
Yeah, we get into the 80s, 90s, except not last summer. You know, it's about the same as last
Oh,
summer.
yeah, last summer they had issues, didn't they? Trying to have the Olympics. Yeah. Is that what you were talking about?
No, I was just talking about how it was a pretty mild summer here.
Yeah. Oh, and it was there
Oh,
too.
man, let me tell you, 6 hours south here in the Ozarks, there's not mild at all.
Nice.
But one of the,
Characteristically mild here, and not really for the rest of the United States.
yeah, but how many years of weather makes up a climate?
10,
Up
30.
About 30, yep. So that's why we're all a little bit hesitant to say that's a swing, but one of the things if we pick on Russia is that if you look at its coldest temperatures, throughout the year and its warmest temperature, that's its annual temperature range. Compare that to Florida. Who has the biggest temperature range? How many people think Russia has a bigger temperature range than Florida?
I don't believe this graph.
How many think Florida? You think Florida has a bigger temperature range than that? Florida has a smaller temperature range, yeah. And so that's one of the things that these graphs can do. But aside from the proximity to the equator and kind of, are you going to have cold temperatures or warm temperatures, these are the 5 factors. We're going to pick them apart, and I'm going to test you over them in a couple of weeks. These are the 5 other things that can affect your general temperature. Okay? And some of them, like you've heard of some of these, right? Like if you live on an ocean or if you live in the middle of a continent, you're going to have different kind of temperature swings. The things about the oceans is the ocean is just, it sucks that energy into kind of like your swimming pool. It's terrible. It's stubborn to heat up or cool down. So ocean's actually going to kind of moderate your temperatures if you live on the coast. The next one, ocean currents. Okay, I'm gonna give you choices are the Atlantic Ocean or the Pacific Ocean. Which one's warmer? How many people think the
Pacific.
Atlantic Ocean is warmer?
Pacific Ocean, it's got the line of fire.
I think the Atlantic's warmer.
I do too.
I know
Actually,
that the Pacific is colder.
The Pacific is colder. It does have the kind of ring of fire going on, but the
It
thing
makes
about
sense,
the
though, because
Pacific.
it's so much bigger.
There's a current, there's a cold current that
Yes,
goes right there.
very good. Yeah, some of you are interested in ocean currents, and actually, there's a big old semi-permanent high that makes it go clockwise here. So, right? And actually, we have a semi-permanent high that makes it go clockwise, but actually, clockwise is good for our East Coast. So, in a kind of a nutshell. Okay, so yeah.
But the North Atlantic, I mean, it just sucks. I don't care what.
I don't know about that. But what about altitude? What do we see on the video? What do you guys know if you go up in the mountain? What's going to happen to the temperatures? It drops, it gets colder, exactly. And we'll talk about that. Geographic position has to do with basically a couple of things, but one of them is how close, like if here's a mountain, like, oh my gosh, North America. We are so, do you guys know, what mountain range is this over here? The Rockies, sometimes I get this wrong. And this is an older mountain range. Appalachians, that's what I would call them, exactly. And you know what? This is so cool. So, you know tornadoes and all that? We are going to look at a map later of where on the earth there are tornadoes. And basically, there's a lot of red dots, right? Kind of here-ish. Okay? Yeah, us, right? But, and in part, it's because of our mountain ranges that go north and south. And we have a pair of them. But my point about geographical position, do you guys know how this works? I don't entirely know how this works, but we'll talk a little bit about it. Depending upon which side of the Rockies you're on, you're going to get a rain shadow on this side. It's going to be dry and have a certain sort of prevailing temperature. And over here, it'll just be a different condition. So that's kind of geographic position. And the other one is cloud cover. We talked about cloud cover, like during the day, what do clouds do? They have a cooling or warming effect. Cooling, exactly. And the night clouds have a warming effect. So we'll kind of revisit that a little bit. So in a nutshell, those are the 5 things other than your proximity to the equator, which we call latitude, that control kind of your surface temperatures. So this is the effect of a large body of water. We're picking on the Pacific here. Okay, so this is California, and the color coding is telling you temperature. So the reds are hot, and the blues and greens are cold. So the other piece of information to make this help have this make sense is it's May, just kind of past spring, right? So we're just starting to kind of get the solar angle going, heading from the equinox into the solstice, hopefully. Okay, we've been getting some direct rays here, and so our land can go ahead and respond and heat up to it, okay? Can you hear it? Okay. But the oceans, and we'll talk about why this is, lag behind with regard to catching on, okay? It's like your swimming pool. Okay, there's a lag there. You know what? I just had a thought. If we were to do a similar thing in September or October, what do you think? The colors might be switched. Okay? The land might be responding to the less solar angle, okay? Cooler temperatures, and this might be delayed in its cooling. So that is kind of taking a look at the coast itself and large body of water. So this actually, the name for this, if you want to circle it at the top, is called a climatogram. So how many years? About 30 or so, yep. About 30 years to kind of put this together for two locations, Vancouver and Winnipeg. And I like what your author's done. In parentheses, he's tried to say why he's trying to highlight about these two. He went ahead and said marine. If you, next to marine, actually you can put coastal. It's the same thing, marine or coastal. And continental or inland, it's the same thing too. Okay? So whenever you try to make a comparison, and if there are 5 variables, like we saw a minute ago, 5 or 6 variables, what you want to do is focus on just one variable at a time. So that's why most of these kind of paired up comparisons, you'll see that they're at least at the same latitude. So they're the same latitude, but clearly one is on the coast and one is inland. So, can you see which one's got the greatest temperature range?
I don't know, maybe it's Vancouver.
Why?
Sarcasm.
Okay, just checking. So in other words, whenever you say something, I should take the opposite.
Sometimes.
Okay.
Case by case.
So Winnipeg has the greatest temperature, I almost said mood swing, has the greatest temperature swing, okay?
Well, I can imagine people's moods would change with that large.
That's true. That's true. And so what you'll hear me say a lot of times is I use the term, thanks for coming, yep. I use the term moderating effect.
Anything moderation or moderating, it's just not good for anything. You always got to get excess.
I think people usually say the opposite, Arlen. Excess should be avoided. Moderation is good. Large bodies of water have a moderating effect on temperatures. Okay. So large bodies of water have a moderating effect on temperatures. Large bodies of water have a moderating effect on temperatures. So I think it really works pretty good if you think of the old swimming pool. When I was growing up, my cousin had a above ground swimming pool. I was one of those. But it took a while when she filled it up for it to. And I don't know if you knew this already or not, but okay, so there's a lot of the Earth is covered with water, right? But did you know that if you look at the southern hemisphere, there's more water? Northern hemisphere, more water. And actually, that's a player later on that we'll talk about. More water, less water. And so what you're looking at is the pole down. This is the southern hemisphere, okay, and this is the northern hemisphere. You're like, we got it going on, right? Maybe, maybe not. If you go to an outback, have you ever gone to an outback and they're, when you step in, I don't know if they're all decorated the same or not, but like they have, if you look at a map, like Australia is southern hemisphere. They have like Australia up here, and they have like the hemispheres are reversed. So just to kind of emphasize this, this is showing you again if you split that where the equator is, 0 degrees latitude, right here, you can see the northern hemisphere and the southern hemisphere. Okay, see we have more and they have more of that. So, large bodies of water have a moderating effect with regard to temperature. The last thing to reveal here is this. Okay, this is temperature swing. Okay, so actually if we go ahead and draw that line back again, northern hemisphere and the southern hemisphere. The southern hemisphere with their oceans and all that, notice that the temperature swing is less. Is less. It's not less, but is less. Okay, so I don't know. I like the northern hemisphere. The southern hemisphere is looking pretty good, except they have like deadly things. Yeah.
Yeah, Australia, everything in Australia wants to kill you.
I know.
But in Australia, like, they say Australia is like the most terrifying place to live.
I
Even
would
in the
think
city.
so. I would think so.
Yeah, spiders are everywhere, man. Spiders are not fun, especially in Australia. Everybody hates spiders. If you like spiders, I can't be friends with you.
I would love to slap
So-
some C4 on a little spider and blow them up.
So this is all about water now. When I said water has a moderating effect, basically what I was saying was this. That water, especially large bodies of water, the larger the more, this tendency. Large bodies of water will cool slowly and they will heat up slowly. And so there are like 4 reasons why that is.
Specific heat.
One of them specific heat, that's right.
I remember I was flipping through the book when I was doing my homework the other day because for some reason I thought all 3 chapters were due today. So
Yeah.
I did all 3 of them.
Oh, okay. But yes, specific heat's one of them. This is another one. The idea of water is mobile versus soil is not. Makes sense. Okay. So when you get it hot, basically you have basically your surface temperature, 20 feet down versus soil, you're like 4 inches down. Okay. Another thing is that water is transparent. Soil is not. Most water is transparent. Mississippi River water, no, not
If
so
you
much.
actually take the river
So-
water out though into a glass, all the dirt settles to the bottom and that's clear water.
Really? Well, that's
Everybody,
Happy
everybody
thought.
sees Mississippi as a dirty, dirty river. It is pretty dirty,
Mm.
but there's dirtier rivers. I can't remember which one it is, but it's.
yeah, and kind of along those lines, like people come from near and far to see the mighty Mississippi. So it's to live where you can go see it whenever you want to is pretty cool.
Especially we're like,
So.
I don't know, 3-4 miles away from, I guess probably 10 miles away from its widest point as well, up in Montrose.
Oh, I guess I didn't realize that. Well, that's neat. Road trip.
Well, and that's a false statement. Some people think it's actually the lightest point. Well, the number doesn't count.
So with transparency, you figure basically the sun's energy can radiate downward, whereas the sun tries to radiate down into soil, and you're like, dude, it's opaque, right? The last one I want to talk a little bit about is the specific heat. And I have a few slides to talk about specific heat. But specific heat of water versus soil. So specific heat is a property of everything. In physical science, we want to know the melting point temperature of everything. We want to know the boiling point temperature of everything. We want to know what everything's made up of. And we may want to know the specific heat of everything. So basically, specific heat is kind of how much it can store heat. Specific heat is how much water is able to store heat, or how much soil is able to store heat, specific heat. So I usually think of it as kind of this little experiment. You see here this 1 gram quantity. Basically, you take 1 gram of the substance, which could be water, okay, and you zap it with energy until it budges in temperature 1 degree Celsius. And that energy is the specific heat. That's the energy per gram degree Celsius. So it kind of goes like that. So if things have a low specific heat, that means you basically just got to tickle them and they scream, the temperature changes, low specific heat. You're like, dude, you don't need much energy and you really have that temperature change, right? Low specific heat, which actually could be a good thing. Air has a pretty low specific heat. Okay? And actually I don't have air up there, it's even lower than 0.8. But I have sandy soil, about 0.8 joules per gram degree Celsius. So it joules the energy, 0.8 joules per 1 gram, budget 1 degree Celsius. So things that have a high specific heat, like water, means you've got to zap it with a lot of energy to get it to budge 1 degree. But once you've zapped it, basically it's kind of a store pot for that energy you had to zap it with. Okay? That's how I think of it. So instead of 0.8 for sand, it's 4.8, 4.18 joules of energy instead of 0.8 joules.
That's a lot of joules of energy just for the river.
It is a lot of joules of energy for water. So this is how this would go. Okay, I can have 2 scenarios, the same amount, 1 kilogram of each, 1 kilogram of water, 1 kilogram of sandy soil. Okay, zap them with the same amount of energy. Okay, but notice what's different about them.
The temperature by 4 degrees.
Yeah, the temperature. Exactly. So have you ever gone to like Pole Miller or something, like a sandy beach, and you know that water's going to be, might even be a little chilly, but you're looking forward to the whole water, but you have to walk through the sand first, okay? If the sun's been shining on both the water and the sand, what's happened is that sand is just, well, they both sucked it up, but that sand has got a low specific heat, and it just goes like, okay, well, I'm jacking up my temperature. Okay, so that's exactly 11 degrees, it's stubborn to heat up, versus the sand. Very good, specific heat. And the last reason that large bodies of water have this kind of moderating effect to kind of, like, I won't change my temperature very quickly, is this idea of liquid water wanting to go to form a gas. Liquid water wanting to go to form a gas. It seems like I said this a little bit ago. Have you ever had liquid on your skin? Yeah, I did, didn't I?
It's a swamp effect or something.
Yeah, it's called evaporative cooling. Yeah, it uses the energy from your body to, so it's got a cooling effect.
That's why your sweat sometimes works.
That's why you're counting on sweating, exactly. You got it. Okay. So here's where we're going to kind of talk about the whole different coasts having different temperatures, okay? On North America anyway, right? So these large ocean currents are great at, remember in the end of like the last 2 slides in chapter 2, we said that there's a surplus here and a deficit here. So somehow we need to kind of move that energy towards the poles. And these ocean currents help to do that. Okay. These ocean currents, and we'll be talking more about this, okay? But the reason, remember I went over here, and if I put an H here, remember I said that the ocean current is going like this. And the only reason that the oceans have movement is because the air above them have movement. And we'll be talking more about that. Okay. So we have kind of talked about this. Let's look at the examples that the author has. Yep, Atlantic. Okay. And actually this part of, it's called an ocean gyre, kind of the big circle, but it's made up of individual currents. So this is the Gulf Stream current coming up, warm, okay. And here they all are. How many gyres are there? I can't remember. But see if you can find the clockwise. We'll be talking more about this later. We'll be talking about a lot of stuff later.
Yeah, Finding Nemo, they were the
That was a good movie, Finding Nemo. Okay, so I'm going to put, what do H's mean on our pressure map? High pressure. I'm going to put an H there, and I'm going to put an H here. And one of the things that I'm going to pound over your head to look at in a later chapter, look for, is clockwise motion around a high. Clockwise motion around a high in the northern hemisphere. I'm going to put one more semi-permanent high here. Do you see the clockwise motion there? Kind of those individual currents connect to make that clockwise motion. What kind of motion do we have in the southern hemisphere?
Probably northern.
Not northern, not clockwise though. Let me put an H here.
Or counterclockwise, because their toilets go backwards.
We'll talk about that, so no, that's a
Not
myth.
a terrifying thing about Australia,
But-
snakes swim up the toilets too, that happens.
It is counterclockwise. Not good.
Go to the geographic, that's not snake, I probably was.
Counterclockwise, okay? All right.
Do their toilets really flush backwards?
Yes.
No. You watch Mythbusters,
Yes.
and they said no.
Really?
Track it down.
Mythbusters is a bunch of crap, though. They're
No,
testing
no,
it in
no,
North
only,
America.
don't talk smack.
They're testing it in North America.
Okay, now listen, really, the thing about the circulating clockwise or counterclockwise in the northern or the southern hemisphere is correct around a central high. It goes backwards around a low. So in the northern hemisphere, actually, it's counterclockwise around a low. So, but clockwise around a high. We'll talk more about that. And it has to do with the Earth spinning, okay? But in order for this effect to work, it needs to be a large body of fluid. It can be air or it can be like water going down your toilet. The thing about water going down your toilet, that it's not a large enough body to be affected by the rotation of the Earth. So
Most toilets now don't even spin, it just goes straight through.
yeah.
Yeah, it's like there's so much pressure.
I want the old toilets back, yeah. Yeah, they say it's more of a physics of the toilet bowl itself.
Pretty gross.
Okay, climatogram. Southern hemisphere, A. But again, they have the Atlantic, okay, and they have the Pacific. One of the things that you're going to want to be able to kind of orient yourself with a little bit is geography. So this is South America, okay? And so here we go down here, okay? And down here, ocean gyres go around a central high, and they go counterclockwise. So over here, they are going to have their, am I doing that right? Yeah. Yeah. Over here, they again are gonna, check that out. Both of our west coasts are screwed. No, I don't know. I'm sorry, you like the west coast, right? But actually, we get cold water, and they also get cold water. Okay? So west coast gets cold water, and east coast gets warm water.
West Coast, it's all the summertime.
That's true, it's always summertime in California.
Now that's not true.
I was just in California like 2 weeks ago.
Was it nice?
Yeah, it was perfect. It's better to go to the ocean in California in the wintertime because it's like a dramatic change. Like, because the water doesn't change temperature, you know, so like when you're cold, when you get in the water, it's still cold, so it's okay.
Ah.
You know where I find the most interesting climate in the whole United States, and it's not here?
Where's that?
Georgia.
Georgia?
It was the craziest weather I think I've ever seen. You know, every morning we wake up, got like 100 degrees. 2 o'clock, we have a storm every day.
That's
Florida's
weird.
like that. I think it rains every day in Florida.
Florida.
Like
Yeah,
South
Georgia.
Georgia, nothing's hotter than South Georgia.
So, hey, what about these two locations? What would you say about their temperature ranges?
They're similar.
I'd say they're similar too. Same moderating effect. But so clearly, though, the one on the East Coast, just like us, what's the difference between the one on the West Coast?
It's warmer.
The whole thing slid up, yeah. Okay, location. Okay, altitude. See, to me, altitude sounds so similar to latitude that it just drives me nuts, but they're two totally different things, right? Latitude is how close you are to the equator, and altitude is like elevation.
Altitude can be latitude if you have dyslexia.
See, it's terrible. Well, altitude, you guys told me it gets colder as you go up. And I'm here to tell you that's really because of a couple reasons. One is because assuming you're standing on something, you're never going to climb out of the troposphere. Okay, even Mount Everest is kind of just still in the troposphere, under the tropopause. So we know that temperatures get cooler as you go up. The other thing is the air gets thinner, and it kind of goes back to a little bit specific heat. With thinner air, yeah, the sun can shine on it, but dang, it's not going to retain any much of a temperature with just those few little sparse particles up there. So as the air gets thinner, it actually has a hard time kind of keeping its thermal energy. So thinning air and going up in the troposphere anyway. Okay, so this is looking at altitude. Let's see if we can see it's looking at altitude. Which one's in the mountains, La Paz or Concepcion? La Paz, exactly. So La Paz is in the mountains, it's blue here, okay? Is this all kind of making sense? In the southern hemisphere, so you see they have winter and our summer, okay, which is okay.
They look like they have winter in their stuff, well, summer or winter in the northern.
Yeah, they're just cold, aren't they? So on the Fahrenheit scale, well, it's kind of a mild winter, isn't it? So they don't have much of a temperature range, about 10 degrees Fahrenheit, is kind of what their temperature range is, and in their winter, they're about 30, so not bad.
What country is that?
It is in South America.
Probably like,
Part of it, look at their, we're at latitude, that's why, look at their latitude.
they're at 20.
Yeah, they're like actually on the equator side of 20. See if we can find them on here. So these, that's 30, 15, it's 23 and a half, so they're, oops. I might have that wrong. Oh, sorry, southern hemisphere, duh. Okay, down here. They're about right here, and so that's why they're so mild.
Can you see what country it is on the globe?
Probably for.
It's South America.
Country, a continent.
Oh. Sorry. Okay. Well, doesn't it say here?
Well, according to the curve, if you put the two curves
Isn't that
together,
Peru and,
it's this little blue one. You just put the curves together. So it's all Peru.
okay. So, yeah, it's 23 and a half. Well, it's kind of, this
Might be
is,
Bolivia too.
yeah, I don't know. I'm not sure.
I think La Paz is the capital of a country, so I guess I could probably just Google that.
Lima's the capital of Peru.
Yeah, what was the capital of Bolivia?
Oh, I see, I think I
Bolivia?
see, I think
Not
Bolivia
La
is, no, it's, I can't pronounce it.
I'm just gonna Google it.
Okay, you do that. I'm gonna go on the next slide. What would you say about their temperature ranges?
They got it going on.
Yeah, it's not much, is it?
But that's like the
Both of them similar.
rainforest.
I don't know. You would think so. I think that it seems reasonable. You got it yet?
Bolivia.
Is that the capital?
So which is in Bolivia?
La Paz.
La Paz is in Bolivia. How about Concepcion?
I think the red outline there is actually the country.
Very good. I don't do geography, obviously. It was on my list of things to learn at one time, and it fell off my list.
It is the capital.
Thank
Also
you.
the highest elevated capital
Okay,
in the world.
very good.
But those are Wikipedia's, so it may not be true.
Oh, I think Wikipedia's probably got that down. Let's go ahead and take a break, and we'll come back and pick up where we left off on Friday. Okay? Well, it won't be Friday.
The Friday portion of the class.
That's right.